To solve for this indefinite integral, we need to use trigonometric substitution. As use substitution will not work in this case. Now, what kind of function out of the trigonometric functions are we to use? It turns out that we are having difference of two squares, whereby the constant term is coming first, which means the expression we are having is of this form: a squared minus x squared. So definitely we are using sine function, that is, x will be equals to a sine theta. So what exactly is the value of a? That will be the square root of the constant value, and therefore a will be equals to 2. So definitely x will be equals to 2 sine theta. Now I will need the x in terms of theta and the theta. So to get that, I will need to differentiate this x with respect to theta, and that will be the x over the theta. What exactly is the derivative of sine theta? That's simply cos theta. So that should be 2 cos theta. Now let me solve for the x. Solving for the x, I should have the x to be equals to 2 cos theta, the theta, by just multiplying both sides by the theta. Now let's substitute. It turns out that the integral will now become x squared. That will be this value raised to the power of 2. And that will be 2 sine theta all raised to the power of 2. And this will be dividing. Whatever we have here, wherever we see x, we just need to replace. That will be square root of 4 minus x is still 2 sine theta all squared. Then everything raised to the power of 3. Perfect. Now the x is simply 2 cos theta, the theta. So I'm just going to replace the x with 2 cos theta, the theta. Now we have everything in terms of theta. We can only just simplify this pairs of trigonometric functions. I would like to expand this. I've just distributed the square, and the integration will become 4 sine squared theta. I believe you got that. Just distribute the square for the whole thing you have within the parentheses. And this will be divided by the root of 4 minus, unlike before, I will also like to expand this with this squared over it. And that will be in the bracket 4 sine squared theta. And the whole thing is raised to the power of 3. Keep in mind, we still have 2 cos theta, the theta. Perfect. I hope you are following. So let me get rid of some space. However, we are still going to need this. So I probably will need to write it somewhere. So we said x is equals to 2 sine theta. That's the written within. So let me just put it away. Perfect. Now, simplifying forward, let me focus more on the denominator for now. So that will eventually be the integral of 4 sine squared theta, all divided by the root of 4 minus 4 sine squared theta, all raised to the power of 3. This is q, and that is multiplying 2 cos theta, the theta. Perfect. Now, what are we to do next? As you can clearly see that we can distribute the cube as well. But before we do that, let's try to make some amendments. This will definitely become 4 sine squared theta, all divided by the root. Since 4 is common, I can bring it out as a common factor. So I'm going to have 4 outside. Now we're left over with 1 minus sine squared theta, all raised to the power of 3. However, I will need to have another bracket right because the 4 is affected by 3 as well. Perfect. So I still have to be multiplying 2 cosine theta, the theta. Very good. Now, we will need to replace 1 minus sine squared theta is the same as cosine squared theta by some of the trigonometric identity. So right now, the integration will become 4 sine squared theta. Let me just multiply this direct. Multiply by 2 cosine theta, all divided by the root in bracket 4, multiply by cosine squared theta, all raised to the power of 3, the theta. So right now, it turns out to be, if I multiply 4 and 2, that will be 8 sine squared theta cosine theta, all divided by the root of 4 cosine squared theta, all raised to the power of 3, the theta. Now, let's distribute the cube that we have over there. So distributing the cube, it turns out that the expression becomes the integral 8 sine squared theta cosine theta, all divided by, so distributing the cube, I'm just going to have the square root of 4 raised to the power of 3, then multiply by the square root of cosine squared theta, all raised to the power of 3. So I tend to like split the radical as well. So that will eventually be 8 sine squared theta cosine theta, all divided by the square root of 4 raised to the power of 3. That will eventually be 8, because that will be the square root of 64. And the square root of 64 is simply 8. 4 raised to the power of 3 is simply 64. So this will be multiplying. Now, the square root of cosine squared theta, all raised to the power of 3, will result in cosine cubed theta, because the square will cancel the square root and we're left with cosine cubed theta. Perfect. Now, you can clearly see that at this point, cosine will reduce cosine. Perfect. And 8 will reduce 8. We should be left over with sine squared theta, all divided by cosine squared theta. And sine squared theta over cosine squared theta, we know that that will be eventually the tan squared theta. Now, we can't really integrate tan squared theta because that might seem a long way. So I would just like to replace tan squared theta with sec squared theta minus 1, because using some of the trigonometric identity, that is true. That is, tan squared theta is equal to sec squared theta minus 1. So therefore, the integral is going to become the integral of sec squared theta minus 1. Perfect. The theta. Okay. I've not been associating theta so far. However, it is there. Good. Now let's expand the bracket. Let's expand the bracket. So this would be the integral of secant squared theta, then minus the integral of 1 d theta, d theta. The integral of secant squared theta, that's simply tan theta. Then minus the integral of 1, that will simply be theta. And this is the integration of your function. However, this will be your final answer. This won't be our final answer because we need our answer in terms of x. So how can we do that? Now back to this, like I said earlier, we are going to be doing this. We can use this to solve for theta. If I divide both sides by 2, we can clearly see that sine theta will be indeed equals to x over 2. And theta will be equals to sine inverse, that is x sine of x over 2. So I'm just going to replace theta with x sine x over 2. Now, what about tan theta? To get that, we can use the triangle process, okay? Since we can always use that to get the sides of those trigonometric functions. Since sine theta is equals to x over 2, so I'm just going to have the right angle triangle this way. We know that sine function connects the opposite side relative to the hypotenuse side. So which correspond that the opposite side is x and the opposite side is 2. So this is 2 and this is x. So what about tan theta? Tan theta connects the opposite side to the adjacent side. So it means we need the adjacent side. To get the adjacent side, we need to use the Pythagorean theorem. What says the Pythagorean theorem? It says the square of the hypotenuse side is indeed equals to the square of the other two sides, that's x squared, plus the adjacent side squared, a squared. So we can clearly solve for the adjacent side squared, as that will be 4 minus x squared. And taking the square root of both sides, I have the adjacent side to be the square root of 4 minus x squared. So right now I can get the value of tan theta. That will simply be the opposite, which is x, divided by the adjacent, which is the square root of 4 minus x squared. And finally, our final answer for this problem will simply be this: x over square root of 4 minus x squared minus sine inverse of x over 2. And this is our final answer plus C. Don't forget to this problem. Hopefully you find this content helpful. If you haven't subscribed to my channel, please do well subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.